28 math questions everyone should know. We're going to have some easy ones, some difficult ones. Try to follow along. What does the word per mean in mathematics? So if I say miles per hour, what does that mean? If I say per, that actually means divide. So when I say miles per hour, I'm really saying miles divided by hours. Briefly describe the understand, solve, explain approach to problem solving. Understand, solve, explain. The understand step is to think about what the problem has to be determined. The solve step is to actually carry out the required explanations. The explain step is to ensure that the result is reasonable. This is very, very important. I have people that answer a word problem with a number, but the number doesn't really make sense if you go back and you look at the question we were asking. So make sure you don't forget to use the explain step to check your work. Does it make sense to say, I drove at a speed of 35 miles for the entire trip? No, that doesn't make sense for a couple reasons. One, 35 miles is not a speed. Speed would have to have a distance divided by time, like miles per hour, kilometers per hour, meters per second. It doesn't make sense. What is the total weight of 7 basketballs that weigh 19 ounces? 7 basketballs, they each weigh 19 ounces. So we're just going to say 7 times 19, and we get 133 ounces. How many inches are in 12 feet? Now, I have some people that are like, oh, I know this. There's 12 inches in a foot, so 1 foot. But no. Let's think about the question we're asking. How many inches? There's 1 foot is 12 inches. So what we want to know is how many are in 12 feet. And you can set this up as a proportion, just like this. Notice that I have feet and feet on the top. And what I want, inches, is lined up with inches on the bottom. Then when I cross multiply and divide, I get 12 times 12 divided by 1 is 144. How many hours are in 14 years? Now, just going to simplify my numbers a little bit, not do leap years, and assume all the days and everything happen like normal. So, in 14 years, we have 14 years. And I need to convert that. I don't know how many hours are in a year, but I'll tell you what I do know. I do know how many days are in a year, so I'm going to use that. I'm going to say in 1 year, there's 365 days. And then that would cancel out years, and then I would have days if I just multiply that together. But I'm going to keep going because I don't want days either. I want in 1 day, how many hours are there? There's 24 hours. And now, if I were to multiply that out, I would end up having just hours, the units I want left. So that would give me 122,640. And that would be hours, because that's my only unit that didn't cancel out. If somebody said it was 110 degrees, if it's 110 degrees, what do they mean? How hot is that? Well, it depends whether you're talking about 110 degrees Fahrenheit or Celsius. Now you might go, what about Kelvin? Kelvin, we don't say degrees, we just say Kelvin. So it's either 110 degrees Celsius or Fahrenheit. And those are radically different numbers. 110 degrees Celsius versus 110 degrees Kelvin. For example, I've been in temperatures of 110 degrees in Fahrenheit, because 110 degrees Fahrenheit, that'd be like, I've been out to Phoenix, Arizona, and been in the desert, and it's been very, very hot, 110 degrees Fahrenheit. 110 degrees Celsius, I haven't been anywhere that hot, because that's hot enough to boil water. That's how hot that is. That is so hot, it would boil, because that's about 240 degrees Fahrenheit. How do you convert among Fahrenheit, Celsius, and Kelvin temperature scales? In order to convert, in Fahrenheit, Celsius, and temperature. It's not too bad. The first thing you need to know is that Fahrenheit is 32 plus 9/5 of Celsius. That's our shortcut. It's not perfect, but it'll get us pretty close. 32 is 32 plus 9/5 Celsius. So if we have 0 degrees Celsius, that's 30 degrees. But if we have 5 degrees Celsius, that's going to be 41 degrees Fahrenheit. Now, if we do the opposite, we'd say Celsius is, now think about the opposite of that. So we're going to, instead of adding 32, we're going to have to subtract 32. And instead of multiplying by 9/5, we're going to say Celsius is Fahrenheit minus 32. And what are we going to multiply by? We're going to multiply by 5/9. There's a couple different ways you could write that out. The last one is Kelvin. For Kelvin, I just say Kelvin is Celsius minus 274. And that'll get me pretty close to the right answer. The Earth has some very deep oceans. The depth of a certain part of Earth's seabed is 36,156 feet. And the question is, how deep is that in fathoms or in leagues? You ever heard of there's a classic book called 20,000 Leagues Under the Sea. How deep is leagues? Well, we're going to take a look at our conversion chart. I don't expect to have these all memorized, but these are customary units. So they have very weird and, specific conversions. So if we look on our chart here, we have fathoms. 1 fathom is 6 feet. So how deep is 36,156 feet? I'm going to go ahead and put 1 fathom over 6 feet. And now guess what? We can multiply those together and the feet will cancel out, which means we're going to go ahead and divide by 6 is essentially what we're going to do. And so how deep is it in fathoms? It's 6,026 fathoms. The follow-up question is, how deep is it in leagues? A nautical league, a marine league. Well, if we look at our chart, it actually says a league is 3 nautical miles. And so we need to go with miles. What's a nautical mile? A nautical mile, it says, is 6,076.1 feet. So we need to do a bit of a trick. We want to get it in leagues. And so in order to get it in leagues, we're going to start with what we have, 36156 feet. And then we're going to multiply by each of our conversion factors. The first thing we need to do is turn it into nautical miles. So I'm going to go ahead and say times 1 nautical mile. And I want to cancel out the feet, so I'm going to put 6,076.1 feet. And now the feet cancel out on the top and bottom. And then convert it into leagues. 1 league is how many nautical miles? 3 nautical miles. So now nautical miles cancels out on the top and bottom. And I can go ahead and multiply straight across, and then divide by the numbers on the bottom. And I get just 1.98. And that is in leagues. A liter is blank times smaller, or blank times as large as a milliliter. A milliliter is smaller than a liter. You should know your metric prefixes, but when we look at this, a liter is how much larger? Well, if we look at milliliter, milli, it says, is 10 to the negative 3. So does that mean 10 to the negative 3 goes here? No, because 10 to the negative 3 would make it smaller. That's how we make it into a milliliter. So we want to go 10 to the positive 3 to make it larger. So a liter is 1,000 times as large as a milliliter. How many quarts are equivalent to 23 liters? In order to do this question, the first thing we're going to need is we're going to need a conversion. So our conversion, I'm going to give you one, and it says for approximate 1 liter equals 1.057 quarts. Those are liquid quarts. Now, how many quarts are equivalent to 23 liters? So we know we want 23 liters. What we don't know is how many quarts that is. So you can see how we can kind of just line up our units to set up a proportion. Do you see the proportion there? A fraction equal to a fraction. And I can multiply diagonally and divide by what's left. And I get 24.3 quarts. If something weighs 14 pounds, then how many kilograms does it weigh? You do not have to have this memorized because we have a little conversion chart here. In fact, we've got 1 pound is 0.4536 kilograms. We also have another one that says kilograms and pounds. 1 kilogram is 2.205 pounds. So we can use either one of those, but I'm going to start by just saying, what am I looking for? I'm looking for 14 pounds. I want to know how many kilograms. And then I can use either one of those. So I'm going to just go ahead and use this first one. You could use the other one. But what I'm going to do is I'm going to make sure I line up my conversion units. So this one, the pounds, are going to go over here with the pounds. And then the kilograms is going to go with the kilograms. And then we're going to cross multiply and divide by 1, and we get 6.35 kilograms. Convert the following temperatures from Fahrenheit to Celsius or vice versa. So we have the formulas right here. The key is that we want to make sure we're plugging them into the correct one. And so the formulas tell us what we want to get. And so the first one, we're going to convert from Fahrenheit to Celsius. So we're going to use this first one because it gives us Celsius. So I'm going to go ahead and plug it in. 55 in parentheses minus 32 divided by 1.8. And then on the bottom, we'd say 1.8 times negative 20 plus 32. And each of those, if we plug them in our calculator, will give us the right answer. And so 55 degrees Fahrenheit, well, that's 12.8 degrees Celsius. And this one ends up being, I'm going to plug it in my calculator here, I get negative 4 degrees Fahrenheit. Don't forget to include your units. Make sure you mark what type of temperature you're using. Let's add together some fractions. But before we try to add them, we need to get them with a common denominator. Because right now, 1/3 plus 1/4, we can't just add them unless they all have the same denominator, the same number on the bottom. So we're going to look for the least common denominator, the LCD, or we could say the least common multiple of what the denominators are. So when I look at that 3, 4, and 5, what could I multiply by each one so that I make them into the same number? And so this is a bit of a tricky question, but we're going to go ahead and say if I multiplied the 3 and the 4 and the 5 by something, I can do something different for each one. They all have to end up at the same one. And so I think the LCD ends up being, well, I'm just going to multiply all of them together. 3 times 4 times 5 is 60. And that's what I'm going to get for my LCD. A shortcut is we could just pick a common denominator by multiplying all of them together and then simplify afterwards. In this case, I don't think we're going to need to simplify. So let's go ahead and go with it. So in order to turn the 1/3 into 60, I need to multiply the top and the bottom by 20. In order to turn the 1/4, I need to multiply the top and bottom by 15. In order to multiply the 1/5 into 60, I'm going to need to multiply by 12. Now that they all have 60 on the bottom, we can just straight add across the top. Our answers are just going to be that 60 on the bottom and that whatever we get on the top, which ends up being 47. We're going to check to see if we can simplify it all, but considering 47's not very easy to simplify, we're going to stop right there. Let's multiply some fractions. I like multiplying fractions better than adding fractions because I don't need common denominators. I can just multiply straight across. So 1 times 1 times 1 is 1. 3 times 4 times 5 is 60. Rewrite this as a common fraction. So this is decimal, but I can turn decimals into fractions actually pretty easily. If I remember, my decimal places are tenths, 100ths, 1000ths. That's because that tells me 179 thousandths is 179 over 1,000. Now, we could try to simplify this, but I got good news for you. 179 does not simplify. We can turn fractions into decimals really quickly, especially if we have a calculator. And so I'm going to go ahead and use a calculator to do it because I'm not going to hold myself to not being able to use just a basic calculator. So if I go ahead and type in my calculator, 17 over 48, I end up with 0.354. Nearest thousandth means 3 decimal places because 1,000 has 3 zeros. So that's where I'm going to leave it. All right, I want to simplify these 3 expressions. I have all of these have 10, power of 10. And so for each of them, I want you to think what they really are saying is 10 to the 3rd is 10 to the 1,000, or 10 to the 8th is 10 to the 8th means 1 with 1, 2, 3, 4, 5, 8 zeros, okay? So as you combine each of these, I'm going to try to keep it simple. This one, what would that end up being? 1, 2, 3, 4, 1, 2, 3. That would end up being something like that, okay? Now that's about as simplified as I can get it. It's ugly in the sense of I can't pull it back into scientific notation or into powers of 10. So this next one, when I see it, I say, oh, I got something a little bit nicer because I'm multiplying this. So this is just going to end up being adding the exponents, 10 to the 11th. Or 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This next one, we have division. So I'm going to subtract the exponents. And so that's 10 to the negative 5. Well, what does that mean? That means 1 over 1, 0, 0, 0, 0, 0. Now we're going to express as a percentage. We have a decimal already, and to turn a decimal into percentage, we just have to multiply by 100 or move the decimal place. So we're going to multiply by 100%, and that'll make that 90%. Now to express a decimal as a reduced fraction, we can do a couple things. The first thing we're going to want to do is turn that 9.90 into 90 out of 100. So we turn that into a common fraction. And then we can cancel out one of the zeros. We can divide the top and bottom by 10. And then we're done. Actually, 9 over 10 is our reduced fraction. Compare A and B in 3 ways, where A is 90.4% and B is 85.7%. The first thing it says as a ratio of A to B. A to B as a ratio. Ratio is really another way of saying a fraction. So we're just going to say 90.4 divided by, and I'm just keeping it in the order it was in. And if I go ahead and type that in the calculator, I end up with 1.05. So that's a ratio. A ratio of 1 would mean they're equal. A ratio of 1.05 means the first group was a little bit bigger. Find the ratio of B to A. Well, we're going to swap the order, right? Now, in the same way, the last one was bigger than 1, so we're going to go a little bit lower than 1. We end up 0.95. Now, if we were to complete the sentence, A is blank percent of B, I want you to be careful. Pay attention to what order we're doing it. A to B. So that's the first one. So we're going to say A is 105% of B. In the following statement, express the first number as a percentage of the second number. So the first number we have is 33,784 versus 20 years later, 47,724. And so we're going to go ahead and write those as a percentage. So you saw that in order to make a percentage, we're going to first make a decimal or a ratio of them. All right, so I have this ratio of two numbers, and if I were to plug it in, I would get a decimal of 0.708, but I want a percent, so I need to go ahead and move that decimal place by 2 by multiplying by 100, and I get 70.8%. Write the number in ordinary notation. What is ordinary notation? Well, that just means this is scientific notation. Ordinary notation would be just without the times and just as a single number. And so this is an 8, but it has a 10 to the negative 6. So normally we'd say an 8 has a decimal place right after it because it's 8.0. But with a negative 6 means we're going to move that decimal place 6 spaces. Since it's a negative 6, we're going to make the 8 smaller. We're going to move it to the left. 1, 2, 3, 4, 5, 6. So my new decimal place is going to be over here, and I'm going to fill in those spaces with zeros. For this number, we're going to write it in scientific notation. It's a very, very small decimal, and so in order to write it in scientific notation, what we're going to want to do is we're going to want to move the decimal place until we have just one number in front of the decimal place that's not a 0. So I'm going to go ahead 1, 2, 3, 4, 5, 6, 7. So we have to move it 7 places. So we're going to say 8.41 times 10 to the 7. But since we moved it to the right, we're going to make it 10 to the negative 7. Now, to think about this, if I said 10 to the 7 and we multiply that out, it would make it a really big number, right? But the number we started with was really, really small. So in order to make it a really small number, we want a negative exponent. Let's say you saw a local news article that said a popular restaurant serves 5 million diners each year, and it's just a single location, 5 million diners each year. That's amazing. In fact, that seems like too much. Now, when I think about it, I might be a little bit skeptical because if it serves 5 million diners a year, that's a lot of zeros. And let's say, well, they're open every day of the year, so how much is that per day? If I take that and divide it by 365, I still get a very big number. In fact, that still means they serve over 10,000 dinners per day. That seems like a lot. 10,000 diners a day. I've been at restaurants that are very, very busy. I've worked in shops that 10,000 is just too much for one location. I'm going to say this claim is false. How many times does the average person's heart beat in a day? Now, we're going to make an order of magnitude estimate, so I don't want a scientific estimate here. I just want something that makes sense roughly with the numbers. Order of magnitude, we don't need to be perfect. We're just in the ballpark. So let's make some assumptions. Heartbeats in a day. I'm going to give you some numbers, and you tell me which one seems. Do you think a heartbeat once a day? 10? 1,000 times a day? 10,000? Now, I think we're on the upper end. I think one time a day, you'd be dead, right? So 10 times a day is not enough. That's not even once per hour. So really, we need to think about this in a sense of let's break it down to something smaller. Like, how many times does a person's heart beat, or how often does a person's heart beat? I think we could probably estimate like 1 per second. Now, if you assume your heart beats once per second, well, we can calculate how many seconds are in the day, and that could give us a good average. Now, I know that sometimes their heart will be up if they're doing exercise, or once per second, or it'll be lower, particularly if they're sleeping, but we're going to go ahead and use that as our estimate. That'll get us a lot closer than just picking a number randomly. So we're going to say, how many seconds are there in a day? That's 60 seconds per hour, 60 minutes per hour, and 24 hours per day. If I multiply all 3 of those numbers together, I get 86,400. So roughly, based on our assumption of 1 heartbeat per second, that's 86,400 times per day. The national debt was about 6.9 trillion at the end of 2003. Assuming the U.S. population was 280 million, express this quantity as the number of dollars per person. So we got a bunch of stuff in this question here that is very helpful. Dollars per person. So I know per means divide. So I'm going to take dollars and divide it by persons, the number of people. I know my dollar amount there, and I know the number of my people. So in order to solve this problem, I just need to take those numbers and take dollars divided by people. In this case, the dollars of 6.9 trillion and the people of 280 million. Now, before we straight up divide these, we have to make these so they're the same thing. We've got million and trillion. So I'm going to go ahead and write those out with zeros. Trillion has a lot of zeros. And so if I would write this out, we've got a big number on top and big number on bottom. But you can see that the number on top is still a lot bigger than the number on bottom. A lot more zeros. So if we divide that, we actually end up with still $24,642.86 per person. How can units help check answers and solve problems? Units are really, really helpful. First off, I want to give you an example. A prescribed dosage of a certain drug is 30 milligrams per kilogram of body weight. So let's say you've got a sick kid and you got to give them their medicine. For a child weighing 15 kilograms, what should the dosage be? Well, if we pay attention to the units, we actually know how to calculate how much medicine to give them, because the units was 30 milligrams over kilograms, milligrams over kilograms. So we have 15 kilograms. We want to know how many milligrams to give them. So we want to cancel those out. And we do that when we multiply. So when we multiply on the top and bottom, it cancels out. And so that tells us we're going to need to give them 450 milligrams. Now, if you're ever unsure about dosage, don't trust your math. If you're stressed, and just talk to your pediatrician, talk to your pharmacist, okay? Don't count on your math when you're sick and delirious to do your own medication. Determine whether the claim makes sense. $1 is worth about 134 Icelandic krona. 1 krona is worth more than $1. So what do you think? 1 krona, is that worth more than $1? Everything's so expensive in Iceland. It costs like $134 for this pack of gum. Well, it doesn't cost $134. It costs 134 Icelandic krona. So does 1 krona, is that worth more than $1? And the answer is I'd rather have $1. Thanks for joining me for some math. Let me know which question you thought was most challenging, or if you thought they were all super easy, all of them super challenging. Let me know in the comments below. I'll catch you next time.